Archimedes of Syracuse, a great mathematician long ago discovered that an object will experience buoyant force equal to the weight of the fluid displaced. We now will be using gizmo simulation in order to achieve our objective, which are to determine the buoyant force by using the formula of Fb equal rho Bg. The second objective is to explain how different density of object affects its buoyancy.
Now, let's move on to our procedure. First, we need to set our boat dimensions to 5 cm for width, length, and height. Adjust it over here to 5 cm each. Okay. Now next, set the liquid density to 2 gram per milliliter over here. Okay. Now press show data because we might need some important information right here for our calculation later on. Okay, now drag 50 gram cube into the beaker on the surface. We assume this beaker as our boat. Drag one. Okay. Notice that we have some water displaced into this measuring cylinder. And it states that the water displaced is 25 milliliter. Okay, record the water displaced and then calculate the buoyant force and tabulate it in our table. Here we calculate the buoyant force using the formula. Now, we repeat again. We add another 1 cube each time until the total of 5 cubes. Okay, we drag it one by one. The second cube. Notice that the water displaced increase to 50 milliliter. Next, the third cube. The water displaced increased to 75 milliliter. The fourth one, the water displaced to 100 milliliter. Now the last cube. Our boat sinks into the liquid tank and the water displaced in the measuring cylinder is 125 milliliter. Now, with all the data that we get, we can finally calculate the buoyant force and we can tabulate it in our table.
First of all, we handle the manipulated variable by using different density of object by adding each block for each step. By doing this, the density of object will increase, which will lead to increase the volume of water displaced in the grad cylinder. Next is for the responding variable. For the responding variable, we handle it by observe and record the volume of water displaced in this grad cylinder. As you can see here, the volume of water displaced increase if we add the block. The volume of water displaced is used to calculate the buoyancy force. Next is important trend. From our experiment, we found out that the increase in density of object with fixed density of fluid, the displacement of water displaced will increase. Then, this also will increase in the buoyancy force. Next, we also proved that when the object is partially or fully immersed, the buoyancy force is equal to the weight of water displaced. So here we can say that the displacement of water is directly perpendicular to the buoyancy force. Next is error and precaution. In our experiment, we faced a few errors. First of all, we do not insert the column for density for object, which is the boat. How we overcome it is we calculate the density of both and insert it into the table. Our second error is we hesitate about the unit needed to be used. We overcome it by doing some research and change the unit into the correct unit. Next is related study. We learned that when the object is floating, the buoyancy force and the gravitational force is the same. Next is for the result. Here is our result. So as you can see here that we fixed the liquid density for 0.02 kg per ml. So for our table result, we have 4 columns, which the first one is volume of water displaced, where the unit is in ml. The next column, we have mass of book or mass of object, where the unit is in gram. The next column, we have density of book or density of object, where the unit is in gram per cube centimeter cube. The formula of this density is mass per volume. Next column, we have buoyancy force, where the unit is in Newton. The formula for this buoyancy force is rho Vg, where is rho for the density of fluid, V is the volume of water displaced, and gravitational force is, and G is for the gravitational force. So here you can see that our mass of object is increased. Then we calculate this mass of object into this formula to get the density of both, and we will get the density of both is also increased. For then, the increase in density of both will also increase in the volume of water displaced. As you can see, here the data is also increased. Then, the last part is, we use all these data into this formula to get the buoyancy force. As you can see here that the data is increased. So the last part is the conclusion. For the conclusion, we found out that the volume of water displaced is directly perpendicular to the buoyancy force. Next, the density of object is directly perpendicular to the buoyancy force. The third one is the Archimedes principle is studied, where it says that the upward buoyancy force getting pushed on the body immersed in fluid is equal to the weight of fluid that the object displaces. The last one is the density of object affects the buoyancy force.